everyone. You are welcome to our lesson for today. In our lesson today, we shall be considering this question. This question is taken from Wassce, June 1997, General Mathematics 2 Theory Questions, and this is the part 1 of this particular question. Now, this question we are going to be looking at today is from Trigonometry. And so if you are just joining us now, I want to welcome you to this channel, Mathefusions. This is a channel where we make maths easy for you to learn. So if you are just joining us once again, I want to say please, you can subscribe to this channel if you have not done so already. Share the videos of these channels with your friends, and you can invite them also into this channel so that they can view all the maths videos here and also suggest to us maths questions you would want us to solve for you. Now let us dive into the lesson for today. This lesson for today is derived from trigonometry, and the question says, given that sine x equals to 5 upon 13, where 0 degree is less than equals to x less than equals to 90 degree, find cos x minus 2 sine x upon 2 tan x. Now, like as I said earlier on, this is a question from trigonometry, and we are having different form of trigonometry where we can split the angles into 4 quadrants. Now, in this particular quadrant, this question deals with the first quadrant, and in the first quadrant, 0 degree is less than equals to x less than equals to 90 degree, which means that this question we have to start from your right triangle. As you can see here, this range of values of x, what this means is that x lies between 0 and 90 degrees. So the maximum angle you can get for x here is 90. And the kind of triangle that has 90 degrees is the one you call your right triangle. So to start up with this question, we have to come over here and draw our right triangle. For me, I will be drawing the right triangle this way. And to indicate that it's a right triangle, we have to put the sign of right triangle here, which is what? 90 degree. Now let us assume that this x is somewhere, say, here. Alright, so now we have to identify the 3 sides of the right triangle. The first place I would like to identify is this side, this length you are looking at now, which is directly opposite 90 degree. So this side is known as the hypotenuse side. Alright, now the other side, which is this length you are looking at now, this side, because it is facing angle x, we refer to it as what? The opposite side. Then the third side is known as the adjacent side. So this is the first thing we are going to do. Now the next thing we are going to do now is to come back to the question. It says, given that sine x equals to what? 5 upon 13. One of the methods we can use in solving a right triangle is Pythagoras Theorem, and the second method is what? Your SOHCAHTOA. So here we are going to start out with your SOHCAHTOA here. In your SOHCAHTOA, we have our SOHCAHTOA. What this means, this acronym means that our sine, to get our sine, it is the ratio of opposite upon hypotenuse. And to get our cosine, it is the ratio of adjacent over hypotenuse. To get our tangent, it is the ratio of opposite over what? Upon adjacent. So what we are going to do now is this. Since we are dealing with sine x, we'll write it out as what? Sine x. Now, for our sine x, we have opposite. As you can see here, O is for opposite. Then the H is hypotenuse. We'll write it out as hypotenuse. And the value for sine x is given as 5 upon 13. So if I come here, I must put equals to 5 upon 13. Now, what does this tell you? It tells you that the opposite side is 5 and the hypotenuse side is 13. Now, we have to take these values for the opposite and hypotenuse and plug them here where they rightfully belong. So for the hypotenuse, we'll write our 13, pardon me for that, please. We'll write our 13, and then for the opposite, we put our 5 there. So you can see that for us to solve anything here, we need this third side, which is the adjacent side. So how do we get this? We can, since we are talking about the relationship between the 3 sides, we are going to be using the what? the Pythagoras Theorem. So we say, using Pythagoras. So how do we use the Pythagoras to solve this problem? Here is how we'll go about it. Since we're using the Pythagoras, it will be the square of the hypotenuse, which is your hypotenuse squared, to equals what? Your opposite squared, then plus your what? Your adjacent squared. Now this is the formula we use for your Pythagoras theorem. Now the hypotenuse is 13, so we put our 13 squared. Then the opposite based on what you have here is what? 5 squared. Then the adjacent, we do not know it, so we can really leave it as adjacent squared. Alright, so what we simply do now is to move this our plus 5 to this side here, so that adjacent square will stand on its own. So we have adjacent squared to equals to, here is what? 13 squared minus 5 squared. Now our 13 is 169. 13 squared means 13 times 13, which is 169. Then 5 squared means 25. And if we subtract this, we are going to have 144. Okay, now since we're having 144, it means that the adjacent squared will become 144. Now we have to remove this square that is here. And how do we do that? We do so by taking the roots of both sides. And if we take the root of both sides, we have the adjacent to therefore becoming square root of 144 will give us 12. Alright, so which means the adjacent side is 12. So we can come to where we have the adjacent side and we write our 12 there. Now we needed to do this so that we can be able to get the ratio for cos x, 2 sine x, and 2 tan x. So what we are going to do now is to get the respective ratios for these, and then we can solve this problem. Now for our cos x, we write it out here. Our cos x. We know that the cos x, based on what you wrote here, is adjacent upon what? Hypotenuse. So we write our adjacent upon hypotenuse. And that is going to give us, what is our adjacent? Our adjacent is 12. And our hypotenuse is what? 13. So we have 12 upon 13. Alright, so this is the value for the adjacent and hypotenuse, which gives us your cos x. The next thing we are going to do now is to get the value for tan x. So we'll write it out here. Our tan x will become, what is the ratio for tan x? We have opposite adjacent. So we have our opposite upon our adjacent. What is our opposite? Well, we come to the diagram. Our opposite is 5. Our adjacent is 12. So we have 5 upon 12. So there you have it, okay? Now the final thing we are going to do before we solve this problem is to evaluate this and this. Here we have 2 tan x. We'll write it out here. Therefore, our 2 tan x will give us 2 multiplied by the value we have for tan x here, which is 5 upon 12. Now, I will advise you at this point to retain the 12 and just go on ahead to multiply the 2 and 5. Then that will give us 10 upon 12. Now, let's come up here and continue this solution. Now, we do the same thing for our 2 sine x. Our 2 sine x would become 2 multiplied by the value we got for sine x. And from the question, sine x is 5 upon 13. So write it at 5 upon 13. And this is going to give us 2 times 5 is 10. 10 upon what? Upon 13. So you have the value for sine, 2 sine x and 2 tan x. So we are going to put these values together. So therefore, we come over to this place. We say, therefore, we write our cos x minus 2 sine x all upon 2 tan x to be equals to the value for cos x. Well, as you can see, the value for cos x is 12 upon 13. We'll write it out to replace our cos x here. We have our 12 upon 13. Then minus 2 sine x, like what you have here, is what? 10 upon 13. So write it out. 10 upon 13. then everything divided by 2 tan x. And from what we have here, our 2 tan x is 10 upon 12. So write it out here as 10 upon 12. Okay, so what do we do here? In the next step, we are going to evaluate this. Now, please take note of this. Since the denominator here and here is the same, we're having 13, okay, they are the same. All we do is to simply subtract the numerator. So 12 minus 10 will give us 2 upon 13. So since the denominators are the same, we collect them as 1, and then we write it as upon 10, then upon 12. Here, we can write this as 2 upon 13. Then this sign means divide. We say divided by what? 10 upon 12. We can still continue this by writing it as 2 upon 13 multiply. If you change from division to times, right, you reciprocate this, meaning 12 will go up and 10 will come down. So it will become 12 upon what? Upon 10. Now from what we got here, 2 can divide itself 1 and divide 10 5. So our final answer will become 1 times 12, which is 12, then divided by, then 13 times 5 will give us, of course, 65. Now, there is no highest common factor between the two of them for us to divide with. So this is going to be the final answer to this question. Now, I believe you understood how this question is solved. Now, please stay tuned with us. We are going to be solving more questions in this channel, and I would like to see you in my next lesson.